When you find a correlation between two variables that doesn't tell you why, sometimes correlation means cause and effect. X causes Y. Doing your homework causes you to do better on the test. Being older causes you to make more money. Maybe, maybe not. What if I'm the ice cream salesman and I want to predict how much ice cream I'm going to sell each day? Do you think that the temperature might have an effect on how much ice cream people buy? Possibly. And this is direct cause and effect. People would buy more ice cream because it's hot out. The second possible explanation is reverse cause and effect. Sometimes people think that X causes Y, but it turns out it's actually the other way around. I think that doing more homework causes people to do better on tests. But what if failing the first test discourages people and then they don't do any more homework after that? It's possible. One classic example of reverse cause and effect is this. A number of years ago, some people came out with a study that showed a strong relationship between having had a nightlight when you were little and being nearsighted and needing glasses when you got a little older. And for a while, there was this big fuss about nightlights damage babies' eyes. This is a horrible thing. We got to ban nightlights, da-da-da-da-da. And then some other researchers looked at the data again and came up with a different explanation. We know that nearsightedness is hereditary. And it turned out what was actually going on was that nearsighted parents were more likely to use nightlights so that they could find their babies in the middle of the night when they didn't have their glasses on. So you don't, trip over toy trains and fall and crack your head open like you're in a cartoon. That's a bad day. So the first group of researchers claim nightlights cause nearsightedness. The second group of researchers demonstrated that nearsightedness causes nightlights. The third possible explanation is a confounding variable. What does the word confound mean? It means to make you really confused so you don't have any idea what's going on. And that's what confounding variables do. They mess up our nice, neat cause and effect. Sometimes you think X causes Y, but there's actually a completely different confounding variable going on. For example, let's say there was a guy who believed that there was some kind of relationship between obesity and school smarts, intellectual ability, that, I don't know, weighing more makes you smarter or less smart, I don't know. So this guy goes to an elementary school and he gives all the kids a reading test. all the kids, same test. And then he weighs all the kids at the elementary school. And he found a very high correlation between how much the kids weighed and how they did on the test. The heavier kids did better. Now, why would that be? Why would heavier children be able to read better? Well, his mistake was he used everyone in the elementary school. The fifth graders are probably heavier than the kindergartners, like a lot heavier. And they also read a lot better. So, rather than finding a real relationship between weight and reading ability, he was messed up by the confounding variable of age. If you did this on adults or on children who were all the same age, I wouldn't expect to see any relationship between your weight and how well you can read. Confounding variables are one of the things that make good health experiments so difficult to do. Let's say I wanted to know, are carrots good for you? Well, the good way to do it would be to do an experiment where I round up 1,000 people and tell 500 of them, okay, you're going to eat 3 ounces of carrots or more every single day. Kids, at least 3 ounces of carrots every day for the next 70 years. And then we take the other 500 and you say, you aren't allowed to eat any carrots. And other than that, you guys are going to eat the same diet, and all of you are going to smoke or not smoke, and you're all going to get the same amount of exercise. All 1,000 of you for the next 70 years. Does that sound like a practical experiment? Of course not. That's impossible. You can do stuff like that with rats. That's one reason why rat experiments are so popular. Because you can take 2 bunches of rats, put them in cages next door, and treat them exactly the same except for one variable that you can isolate. And rats don't live very long. Their natural lifespan is like 2 years. So you can follow them their whole lives. Of course, rats aren't people. So we really want to know, what is the health effect of a human eating carrots? Okay, we can't do a 70-year experiment. So I know, let's round up a bunch of people, measure their health, and ask them how many carrots they eat. And if we find that the people who eat carrots are living longer, having fewer chronic diseases, then we can conclude carrots are good for you, right? Not so fast. Most people out there already believe that carrots are good for you. They're a vegetable. They have lots of vitamins. They probably are good for you. However, the people who are eating more carrots might also be making other good health choices. They might be less likely to smoke. They might be more likely to eat other vegetables. They might be eating less cake and French fries. They might be driving more carefully and buckling their seatbelts. So this is a major issue in trying to study the health effects of human lifestyles, that people who make one healthy choice tend to also make other healthy choices. And people who make one bad choice may be making other bad choices. So, confounding variables. The fourth possible explanation is coincidence. Sometimes you go out, you collect some data, and you think you found a correlation, but in fact, it's just a coincidence. That's possible, and it's worth considering. So, let's look at a few other examples of confounding variables. Sometimes what you find is that there's a relationship between x and y, but the confounding variables make it look stronger than it really is. You may have seen articles that claim that breastfed babies are smarter, are healthier at age 20, live longer, etc. The problem with some of these articles is that they didn't properly control for confounding variables. Just like with the carrots, I can't round up 1,000 new mothers and tell half of them you must breastfeed exclusively for 6 months, and the other half you're not allowed to breastfeed at all. That would be outrageous. There are various factors that affect whether or not mothers breastfeed. Sometimes it's economic. Some mothers can't afford to take a long leave, and formula is pretty cheap. In fact, if you are poor, you can get formula for free. Sometimes it's medical. There are various medical reasons why a mother might not be able to breastfeed, and some of those medical factors could affect the infant one way or another. Family support. There is a relationship between how much education a mother has and whether or not she breastfeeds. So it's not a simple relationship. The studies that properly control for confounding variables found that the difference between breastfed and non-breastfed babies is 1 illness in the first year of life. One, like, stomach bug or whatever in the first year of life. And, if you're living in the third world, that might be the difference between your baby dying and not. Here, really no long-term difference. So breastfeeding is better, but the magnitude of the better is smaller than some advocates would have you believe. Confounding variables.